Hello everyone and welcome to our booth here at FAC 2022. My name is Jakob and I'm here to present our conference paper, Models for Classifying AI Systems, the Switch, the Ladder and the Matrix. Before delving into the material, I want to say a few words both about the team who has co-authored the paper, but also about the problem that we're trying to address. Let's start with the ladder. So with Models for Classifying AI Systems, we refer to mental models of how to define the material scope of AI governance. And this is a very practical problem. We have seen policymakers and technology providers and academics grapple with the question, to which systems and processes do additional layer of governance apply? And I want to be very clear up front. We're not trying to propose a new definition of what AI is, nor compare definition of what AI is. Rather, we're looking at what are models for how to classify AI system for the practical purpose of AI governance. We'll come back to that in a while. The second point is that this is a highly multidisciplinary area that draws on both computer science, but also organizational studies. And this also reflects the list of authors on the paper. I, for one, am a last year PhD student at the Oxford Internet Institute. I have a dual background in social science and engineering. Margi is a practitioner working with the R&D data office on AstraZeneca Cambridge. David is currently at the UCL Computer Science and Statistics Department. Professor Luciano of Floridi, who's also my PhD supervisor, has the dual chair, one in philosophy here at the University of Oxford and one in sociology of the University of Bologna. So I'm representing the team here today, but let's delve into the presentation. The presentation is divided into 4 parts. In the first part, I will talk about the background, why models for classifying AI systems are needed. In the second part, we will look at a theoretical framework and define criteria for what constitute good classifications of AI systems. So we will see that you can do it in many ways, but not always are good ways. In part 3, we'll discuss our findings. And what we have done here specifically is that we have, through a systematized literature review, clustered various and previous attempts to classify AI systems into 3 approaches or mental models that we call the switch, the ladder, and the matrix, respectively. We'll come back to what this means when we get there. And in the fourth and final part, we will compare the relative strength and weaknesses of different mental models for classifying AI systems. If we take a step back and look, why is AI governance needed in the first place? We see that this is actually a confluence of pressures. So it's neither a purely top-down mandated need, nor is it purely a bottom-up need, but we see that both of these components play a role. For example, if we start with top-down, in both EU, in the US, but also in other regions of the world, policymakers have drafted hard legislation to ensure that AI systems are ethical and technically robust. To give a few examples, in the EU we have the Artificial Intelligence Act that was released last year in 2021. Currently in the US, the Algorithmic Accountability Act of 2022 is being discussed. So there is a top-down pressure for democratic legitimacy. But we also see in parallel that there is a bottom-up approach whereby technology providers who either design but also use and employ AI systems, they have an interest in knowing what these systems are doing and also being able to govern them for a multitude of reasons, for brand management, risk management, but also quality management. And we have seen backlashes both in the more technical industry, such as the famous examples of Google image search, but also in the more traditional industry, such as with Volkswagen's car manufacturing algorithm, who deceived tests in certification procedures. But the main point I want to make here is that the need for AI governance is both top-down and bottom-up, and it also draws on a multidisciplinary background with influences from political and moral philosophy on the one hand and international relations. At the same time, we will see many of the actual practical influences comes into systems engineering, quality management, and this meets then in organizations that are trying to implement this legislation, but also quality management in legal studies and organizational studies. But what is governance without the material scope? A key feature of governance is that it needs to demarcate its material scope. And as we have seen, many organizations have committed themselves to AI ethics principles. However, the material scopes, that is to which systems or processes this apply, have often left open for interpretation. And this is not unusual. Of course, we know that there is no universally accepted definition of AI, and nor maybe can there be, nor should there be. However, what is problematic is if we introduce new legislation or new corporate policy without a clear material scope, because then there might be question as to which system or processes these new framework and governance mechanism actually apply. So it's very important for a couple of reasons to have models for how to classify AI system. One is to enable implementation. If we don't know for use case A or B whether our AI governance frameworks apply, they might be applied inconsistently or on an ad hoc basis. The second is if there is no way of classifying AI system, it's hard to measure success. And finally, it's impossible to demonstrate compliance. So in short, every policy needs to define its scope of application, and governance is most effective when applied in ways that are fair, transparent, and consistent. Drawing on a very pragmatic stance, however, we want to stress here that this is a problem we cannot circumvent. Even if we don't like classifications, and even if we don't want to add additional typologies and split hairs about what is or is not AI, in order to have an operational policy within an organization, you need to categorize things into groups that enable proactive actions. And for those interested in pragmatist philosophy, a quote by Dewey to support the same. However, only because you need to classify AI system doesn't mean that all ways are equally good. For this reason, we will now move on and look for what are actually criteria for a good classification of AI systems. So for the purpose of this paper, we have included 3 criteria for what constitute a good classification of AI systems. Such classification should be fit for purpose, simple and clear, and stable over time. Very briefly, fit for purpose means that classification should neither be over or under-inclusive. An over-inclusive policy applies to too many systems. That means that we subject the organization to unnecessary administration. On the other hand, an under-inclusive definition would mean that we fail to capture systems or processes that pose high risk and that actually require governance. Simple and clear means that practitioners within the organization should know when and when not to apply the governance framework. It should not be confused. Stable over time means that we want to be able to have this classification and use it over several years so that we don't base it on features that are likely to maybe change in the near future. And if we summarize this, that means that a good classification should specify to which systems that AI ethics principle apply, help practitioner determine which class of AI system, if any, a particular use case belong, and C, provide a resilient basis for AI governance over time. Now, let's look at the findings of this paper. And the findings are based on a systematized literature review of previous attempts to classify AI system. So this is a synthesis of what is already out there in the literature, but the reason why we have used mental models is to make it more easy to remember and also to facilitate the discussion within policy-making groups, but also within technology providers. So the first mental models for how to classify AI system we have called the switch. This is a binary approach according to which systems either are or are not considered AI system based on their intrinsic criteria. So the basic idea is here to list a number of minimal requirements, and if these are satisfied, then the AI governance framework applies, and if not, no action is needed according to the AI governance framework. There might still be other reasons to apply governance, maybe such as corporate social responsibility or sustainability. But the basic idea is that there's a definition that serves as a threshold, and over that threshold, AI governance apply. And one example here is the IEEE series 7010. Where an AI system is considered a semi-autonomous or autonomous computer-controlled system programmed to carry out some task with or without limited human intervention, capable of decision-making by independent inference, and successfully adapting to its context. And as you see, there's a number of criteria, such as autonomous or semi-autonomous, but also that, for example, is capable of decision-making by independent inference. So we see that a thresholds approach is used, and this is one example, but not the only, on the switch. The second approach to demarcate the material scope of AI governance we have chosen to call the ladder. And this is a risk-based technology agnostic approach where it's less important what kind of technology the system actually is from an ontological sense, and more important what risks it poses, whether it be social, ethical, or legal risk. So the basic idea here is to classify AI systems into different risk levels and thereby approach their governance in a proportional sense. And we could say here that actually it's agnostic as to which technology go into it, and even if it's maybe a human decision maker in some cases or a computer-centric decision makers. The idea is for the lowest risk system, no governance is needed. For the highest risk system, they might even be prohibited. And in between, you have an area with risk levels for which AI governance frameworks apply. A classic example here is the German Data Ethics Commission, who proposed a risk-based framework a few years back, and this has since been adopted also in the European Artificial Intelligence Act. The reason why we don't use that as an example here for the latter is that in the European Artificial Intelligence Act, there's first a switch that demarcates the broad scope, and then a ladder that changes the risk levels for different policy responses within that scope. And this shows how these different mental models can be combined and used also within the same organization or legislative framework. So we will get back to that in the end. The third and final mental model is the matrix. And here, the basic idea is that you take multiple criteria into account to determine what a policy response ought to be, or which type of governance framework applies. So, for example, you look at a use case and you determine what is the use case, what is the input data, which decision-making model is used for which fairness criteria, and given a specific combination of this, that mandates a certain governance response. And that is why we have chosen to call it the matrix. And one example on this is the recent OECD framework for how to classify, or in this case, define AI governance according to a framework based on 4 dimensions. One is context, that is the environment in which the AI system is deployed. Another is data input, and that is, of course, then the data that goes into the AI model. But it also matters which AI model is used, that is, which computational technique is employed. And finally, of course, the task and output, that is the impact the system have or the output distribution. And as we will see, this is a very precise way of maybe demarcating the material scope, but it also adds some upfront administration cost for the organizations trying to implement such a classification. With those 3 mental models in mind, let's proceed and look at the relative strengths and weaknesses of different models for classifying AI systems. So if we look at our basic criteria for what is a good classification, we want them to be fit for purpose, simple and clear, and stable over time. And what we can see here through the comparative analysis, as there is a 3-way trade-off. Start with the switch, for example. Its advantage is that it's simple and clear. If you define criteria or a threshold, it's easy for practitioners to determine whether or not to apply the AI governance framework. However, classification based on the switch often end up being either under or over inclusive, and therefore they're not always fit for purpose. Also, because you define the threshold, they may not be stable over time because different parameters might change as technologies evolve. The latter, on the other hand, because it's technology agnostic, is highly stable over time because you focus on the risk the system poses. On the other hand, it's not always simple and clear how, for example, to define risk can vary between organizations and between departments and technologies within an organization. Finally, the matrix is a highly fit for purpose model for how to classify a system, insofar as it gives very specific policy responses. Unfortunately, it's not very simple and clear, and this is because it adds upfront cost in project to determine all the parameter that goes into an AI system upfront. With that, I now open up for questions, either in person or online. Looking forward to continuing the discussion. Thank you.